magnitude and direction of the magnetic field at a point A, which is halfway between the wires. And we also want to find it at point B as well. Alright, so first thing I would do is imagine grabbing the wire with my hand using the right hand corkscrew rule. Okay, when you do that, you point your thumb in the direction of current for the upper wire, right? And then what happens is we see that the fingers are going into the page above the wire, but they're coming out of the page when it wraps around to the bottom part. So what we want then is we want X's above this wire and then dots below it, just to show the direction of the magnetic field, how it's going into the page above the wire and out of the page below it. But now you got to do the right hand rule on both wires. Okay, but when you do that, you see that the fingertips are pointing out of the page above this wire and they're going into the page below it. So that just helps us sketch the magnetic field around these wires. So it looks like both wires are going to contribute a field coming out of the page in the middle section. Alright, what we want to do is we want to get the distance that point A is from the first wire. It's 2 meters apparently. I'll call that D1, and this can be I1. Here's I2 and D2. So at point A, we need the B due to wire 1 and the B due to wire 2 added together. Now we have formulas for those. Alright, so our formulas are mu naught I1 over 2 pi D1 and mu naught I2 over 2 pi D2. We'll have this. First wire carried 12 amps. Second wire carries 14 amps. Alright, then we just want to punch that into calculator. 2.6 times 10 to the minus 6 Teslas. And lastly, if they want the field at point B, that's a little tougher actually. Here's why. The contribution to the field at point B due to the upper wire, it would be out of the page. But the contribution due to the lower wire would be into the page. So they would be at odds in this case. So I might make a note of that just here, that B1 points out of the page at point B. That's due to the right-hand rule being done on the upper wire, right? But B2 points into the page at point B. So that's something to consider when we do our calculation. We just want to make sure that that we do a subtraction instead of an addition. Okay. All right, so let's do the calculation. B total, and this time I'll make it a vector. This is at point B, is going to be mu naught times I1 over 2 pi d1, but maybe I'll call it the distance from wire 1 to point B. I'll just notate it that way this time. This is going to be out of the page, so I'm going to put positive k hat on that. Then we'll use I2's current, and I'll do the distance from 2 to point B. But this is in the negative k hat direction. All right. Let's put in our numbers. The distance from the upper wire is actually 2 plus 2 plus 2, which is 6 meters. But the distance from the second wire is only 2 meters. Okay, that would be our calculation. I'm getting negative 1.0 times 10 to the minus 6 Teslas. Put a k hat on the end. Okay, it tells us into the page.